Today we are talking about converting from standard form to vertex form. Okay, and as a reminder, standard form was f of x equals ax squared plus bx plus c, and vertex form is f of x equals a times x minus h squared plus k, where hk is your vertex. So our first method is completing the square. For now, only use this when a equals 1. So here's how we do this. So for the first problem, let's say y equals x squared plus 6x plus 7. I could have said f of x equals, I just chose y. I could have said g of x, h of x, doesn't matter, right? And so this is standard form, and I want to turn it into vertex form. And so to do this, what I'm going to do is I'm going to say x squared plus 6x, and then I'm going to leave a space and put my plus 7 and leave another space. So you'll always put your spaces there. And the idea behind completing the square is we're going to make x squared plus 6x plus something into a binomial squared. So we'll take 6 over 2, which is 3, and we're going to add 3 squared. Then after the 7, we're going to subtract 3 squared. And we add and subtract because then the net effect is 0, so our equation value doesn't change. That's why we're allowed to do that. And so now what we have is y equals x squared plus 6x plus 9, and then we have our plus 7 and we have minus 9. So x squared plus 6x plus 9 is x plus 3 squared. You might just know that, but also just know whatever you got when you did 6 divided by 2, it's going to be x plus that squared. And then 7 minus 9 is negative 2, so we have x plus 3 squared minus 2. So this is x squared plus 6x plus 7 written in vertex form. For our second problem, let's look at y equals x squared plus 4x plus 1. So our first step is to take x squared plus 4x, and then put a space, and then put our plus 1, and then put a space. 4 over 2 is 2. So we'll add 2 squared, and then we'll subtract 2 squared. Again, we're adding and subtracting because we need to have the net effect be 0. So we have x squared plus 4x plus 4, and then we have plus 1 minus 4. X squared plus 4x plus 4 is the same as x plus 2 squared, again, because it's always x plus whatever was right here when you divided that number by 2. And then 1 minus 4 is negative 3. So that's our equation in vertex form. For the third one, let's do y equals x squared minus 2x minus 15. We have negatives, but we'll do it the same with the same general process. So we'll take x squared minus 2x, and then we'll put a space. We'll put our minus 15, and we'll put a space. Now negative 2 over 1, or I'm sorry, negative 2 over 2 is negative 1. Okay? So I'm going to have to rewrite that 2 because it's going to bother me. Negative 2 over 2 is negative 1. So we're going to put a plus negative 1 squared and a minus negative 1 squared. So this is y equals x squared minus 2x. Negative 1 squared is 1, so we have plus 1. Minus 15, negative 1 squared is 1, so minus 1. So now, x squared minus 2x plus 1, since this value is negative 1, this is x minus 1 squared, okay? Because it's x plus negative 1 squared. Negative 15 minus 1 is negative 16. So there's our function in vertex form. Okay, so that's what we will use when a equals 1. Again, a is just the coefficient in front of the x squared. You can use it when a has other values, but it's not necessarily that efficient. So for our second method, we will basically find the vertex and go from there. And this we can use anytime. But be able to complete the square when a is 1. It's a good skill to have. So for our first problem, y equals negative 1/2 x squared minus 4x plus 6. So we're going to find our vertex. So our x value is negative b over 2a, which is a negative negative 4, which is 4, over 2 times negative 1/2. This is 4 over negative 1, which is negative 4. So that means the x-coordinate of our vertex is negative 4. And now let's find the y-coordinate. F of negative 4 is negative 1/2 times negative 4 squared minus 4 times negative 4 plus 6, which is negative 1/2 times 16. Negative 4 times negative 4 is positive 16 plus 6. So that's negative 8 plus 16 plus 6. Negative 8 plus 16 is 8, plus 6 is 14. So then our vertex is negative 4, 14. And then we just need our a value. And our a value is just always right out here in the front, whatever is the coefficient on the x squared. So then a is negative 1/2. So then in vertex form, we have y equals negative 1/2. Our a is just out front, x minus the x-coordinate of the vertex. X minus a negative 4 is x plus 4 squared plus the y-coordinate of the vertex. So y equals negative 1/2 times x plus 4 squared plus 14. Now let's do y equals 2x squared plus 4x minus 5. For the x-coordinate of the vertex, x equals negative b over 2a, so negative 4 over 2 times 2, which is negative 4 over 4, which is negative 1. F of negative 1 is 2 times negative 1 squared plus 4 times negative 1 minus 5. 2 times 1 is 2, minus 4 minus 5, which is negative 2 minus 5, which is negative 7. So our vertex is negative 1, negative 7. A, let's look right here, a is 2. So in vertex form, we have 2 times x minus a negative 1, which goes to plus 1, minus 7, because we just tack the y value on at the end. Let's do one more. Y equals 3x squared plus 18x plus 23. You're always welcome to pause and try it on your own and then come right back. Our x-coordinate will be negative 18 over 2 times 3, which is negative 18 over 6, which is negative 3. F of negative 3 is 3 times negative 3 squared plus 18 times negative 3 plus 23. This is 3 times 9, 27. 18 times negative 3 is negative 54 plus 23. 27 minus 54 is negative 27, plus 23 is negative 4. So our vertex is negative 3, negative 4. A, it's right here, a is 3. So then y equals 3 times x minus a negative 3, so plus 3 squared minus 4.